Okay, diving into Unity's GraphView API.
Sounds like someone's looking to level up their game dev skills.
Absolutely. And to help us on this journey, we've got two YouTube videos from the Game Dev Guide channel.
Think of them like our roadmap for exploring this API.
A roadmap, I like that. So what's so special about this GraphView API?
Well, it's kind of like this hidden workshop in Unity,
Mhm.
where you can build all sorts of visual tools, but the instructions are a little bit all over the place.
Yeah, they can be tricky.
Luckily, these videos walk us through building a node editor from scratch.
Oh, nice. From scratch.
Yeah, which is a great way to really see what it can do.
Makes sense. The creator even mentions that Unity hasn't fully explored everything the API can do themselves.
It's like we're getting a sneak peek behind the scenes, right?
Exactly. So before we get ahead of ourselves, can we take a step back? What exactly is the GraphView API and why should we even care?
Okay, so imagine this. You're building a complex game system, maybe like a dialogue system with branching paths, or even a procedural level generator.
Yeah, I'm
Well,
following.
instead of just like wrestling with lines of code, wouldn't it be great to visually lay out that logic?
Oh, visually.
Yeah, connect all the pieces like a puzzle and see the whole system come to life in front of you.
I can see where you're going with this.
Well, that's what the GraphView API lets you do. It's like a framework for building node-based editors within Unity.
Node-based editors. Okay. Is that something similar to like blueprints or something?
You could think of it that way.
Yeah.
And it's surprisingly versatile.
Okay, versatile. So I noticed in the video that it's labeled as experimental.
Yeah.
Should that be a red flag?
That's a good question. And it's actually kind of funny because even though it has that experimental tag, the GraphView API has been around for a while.
Really?
It's actually already used in some of Unity's core tools, like Shader Graph and VFX Graph.
Oh, right. Those are pretty popular.
And they're used in tons of games, so it's definitely robust.
So it works.
It works, even if it hasn't officially graduated to, official status yet.
So it's like a hidden gem.
It is. It is. Unity is working on a successor called Graph Tool Foundation.
Oh.
But for now, GraphView is a super powerful option.
Okay, so it's safe to say that it's reliable.
You can count on it.
So kind of like a secret weapon we can use to create some really cool stuff.
Exactly.
Speaking of cool stuff, in the videos, the creator builds a visual scripting tool,
Right?
as an example. Why go with that?
Well, visual scripting is just a really great way to demonstrate how flexible the API is.
Yeah, okay.
You can see how nodes represent code, how data moves between them.
The flow?
Exactly, the
Yeah.
flow, and how that logic actually gets executed.
Okay, so you can visually see how it works.
Yeah. And, a lot of developers are into visual scripting.
It's definitely become more popular.
It's a more intuitive way to program.
I think so too. It's like, what's that, building with Legos or something?
Yeah, exactly. Except the blocks are code and the creation is a game mechanic.
I like that analogy a lot. And what's also cool is that the creator's approach shows that you can build tools that are similar to those popular assets like Bolt or Playmaker, but you can really tailor them to your exact needs.
You're not stuck with what's already out there. You can build the perfect tool.
That level of customization is pretty awesome. And it's not just about reinventing the wheel either.
Right.
The creator goes into some interesting applications beyond just basic visual scripting.
Yes.
There's a part about procedural geometry, right?
Absolutely. In the first video, they actually show off a custom editor that they built for procedural geometry.
Okay.
Imagine creating complex 3D models, but you're doing it by connecting nodes.
Oh, interesting.
Kind of like a visual programming language, but for 3D modeling.
Instead of code, it's like these nodes, like visual representation.
Exactly. Each node would represent a specific action, like
That's-
creating a grid of points, generating cubes at those points, merging meshes.
So you're visually building these models.
You could build levels, characters, even abstract art using this kind of system.
That sounds incredible. It would be a total game changer for prototyping levels or coming up with crazy art assets.
It would. It would.
Okay, so I'm starting to see the potential here.
Good, good.
What other examples did the creator mention?
They also talked about event sequencing tools.
Okay.
Imagine being able to lay out all the steps of a cutscene,
Oh, wow.
all visually using nodes, from the dialogue to the character animations, camera movements.
So it's very visual. It's not just code.
Exactly. It would
Yes.
streamline the whole process
Streamlined. Okay.
and make collaboration between designers and programmers so much easier.
And didn't they mention AI behavior trees?
Oh, absolutely.
Hmm.
Think about creating an AI character's decision-making process.
Okay.
You could have nodes for conditions like
Like, is the player nearby?
exactly, or actions like attack or flee
I see. So you could create complex AI behaviors?
without writing any traditional code.
That would be a game changer for designers who might not be as comfortable with, hardcore programming.
Right. It could really open doors for them.
So the GraphView API, you can use it for visual scripting, procedural generation, event sequencing, AI.
It's like the Swiss Army knife.
It really is. But enough teasing, let's get into how it all works.
Let's do it.
In the videos, the creator walks us through building a visual scripting tool from the ground up.
Yep.
What are some of the core concepts we need to understand here?
All right, well, think about building a house.
Okay,
You always start with the foundation.
the foundation really.
Well, in this case, the foundation is Unity's UI toolkit, and we use that to create a custom editor window.
Oh, okay. So that's our workspace.
That's our workspace.
Got it. So what's next?
Then comes the fun part,
Right.
defining the building blocks, or in our case, that would be the node classes.
Node classes.
Yes. And each node represents a piece of code or a specific functionality, like moving an object, playing a sound, even making a decision.
Yeah.
And the creator uses this clever system of attributes to decorate these classes.
Attributes. All right, I'm listening.
That's where the magic happens.
The magic, all right. Tell me more.
So imagine you want a node that makes a character jump.
Okay, jump node.
Right. You could create a class called JumpNode, and then use attributes like NodeInfo to tell Unity how that node should look in the editor.
Oh, so you can control the appearance?
Yeah. You can give a name, put it in a category, even change its color.
So it's not just about the functionality. You can really customize the look.
It's all about making it clear and easy to use.
I see. So we've got our editor window, our node classes, all dressed up with these attributes.
All set up.
But how do we actually add those nodes to the graph?
Good question. It's not as simple as just dragging and dropping.
Figured as much.
The creator sets up this really cool search provider.
Search provider.
So you can just press spacebar in the editor window and start typing to find the node you want to add.
Oh, that's cool. So it's like a Google search for your nodes.
Exactly. It's super efficient.
Mm-hmm. Makes a lot of sense, especially if you have a ton of nodes.
Right. Much better than scrolling through endless menus.
Okay, so we can add the nodes, but how do we connect them?
That's where ports come in. Think of them like the doors and windows.
Of our node house.
Exactly. Each node can have input and output ports, which are these little connection points.
I've seen those before.
And you can draw connections between them.
I see, so it's all visual.
Totally. And that's how data travels from node to node.
The flow.
The flow. So,
Yeah.
for example, you might have a node that gives you the player's speed,
Okay.
and then you connect that to a node that controls the animation speed.
So it all links up.
Exactly. Everything is connected.
So we've got these nodes with ports, the connections carry the data. It's looking like a real visual scripting system.
It's coming together, right?
But how does it actually run in the game? Do we just hit play and everything magically works?
Not quite magic. There's a runtime controller.
Runtime controller, that sounds important.
It is. It is.
Yeah.
It's like the foreman on a construction site, making sure everything runs smoothly. We attach this component to a game object in our scene,
I see.
and it's responsible for reading that node graph, understanding the connections and executing the logic in the right order.
Okay, so the runtime controller basically interprets what's happening in the graph.
It takes those instructions and turns them into actions in the game.
That makes sense. I think I'm starting to get the big picture here.
Great. All right. Welcome back to our GraphView deep dive. It's awesome to be diving even deeper into this API.
Yeah, I'm excited to keep going. Last time we left off, we had that basic visual scripting tool, and we even got a cube moving around based on our node graph.
Yeah. Remember that.
It felt pretty amazing seeing that cube move, knowing that we built the system that made it happen.
It's always a good feeling.
But now I'm wondering how we can make this even more powerful and flexible.
Okay. I like where your head's at. In the second video, the creator tackles something super important: handling data flow between those nodes in a more robust way.
Robust.
Think of it like setting up really clear communication channels between all the parts of the system.
Okay, I'm intrigued. So are we talking about something beyond those basic connections we set up? Like where we visually link the input and output ports?
Exactly. Those visual connections are a great starting point. But now we have to define the types of data that can flow through those channels.
Okay, so like making sure we send the right kind of message.
Yeah, like you wouldn't send a text to someone who's expecting a phone call,
Yeah,
right?
get it. That makes sense.
So to make sure our nodes are communicating effectively, we need to make sure they're sending and receiving the right types of data.
Okay, so how do we do that?
The creator introduces the idea of port types,
Port types.
They're like labels for the different data categories.
Fair.
Things like floats, integers, booleans, even custom data structures.
Okay, I'm following. So, like, different languages our nodes can speak.
That's a great way to put it. It's all about making sure the nodes can understand each other.
Makes sense. This reminds me of type safety in programming, where you can't accidentally mix up incompatible data types.
That's a great connection to make. It's the same principle here. By assigning these port types, we make sure that only compatible nodes can be connected.
Right, because mixing them up would just mess everything up, right? It would break our game logic.
Chaos. But by using port types, we're preventing errors and making sure the information flows logically.
So it's a safety net.
It is. So how do we actually define these port types?
Do we have to create a whole separate class for every single data type?
Thankfully, no. The creator uses a really elegant approach. A simple enum.
Enums, okay.
Think of it as a master list of all the data categories we want to work with.
A master list.
Yeah, and when we create a port, we just assign it a value from that enum to specify its type.
Ah, so we have this central registry for all our port types, a universal translator. That's much cleaner than creating a bunch of separate classes.
Exactly. And this enum becomes really handy when we need to check if two ports are compatible.
Okay, yeah, compatibility, that makes sense.
The creator does this by overriding a method in the GraphView class called getCompatiblePorts.
Get compatible ports, got it.
This method acts like a matchmaker for our ports.
Oh, a matchmaker, okay.
It figures out which ones can connect based on their types. Using the port type enum, we can compare two ports and see if they're speaking the same data language.
So every time we connect nodes, Unity's running this compatibility check in the background, making sure we don't make illogical connections.
It's working hard behind the scenes. But, speaking of cool things, do you remember the serialized reference attribute from the videos?
Oh, yeah. The serialized reference attribute, it sounded pretty powerful.
It is a game changer. It lets us serialize references to any Unity object that inherits from Unity Engine.
Hold on, I'm trying to remember what serialization is all about. I thought it was mainly for saving simple data, like numbers or text.
It is, but serialized reference takes it a step further.
Okay.
It allows Unity to save those references to objects, not just the values.
So we can serialize an entire object.
In a way, yes. It's like embedding a mini version of the object into our Node.js data.
Okay, I need a real-world example to wrap my head around this.
Let's say you're making a dialogue system using GraphView. You've got a node that triggers a character's animation when a line of dialogue is spoken.
Okay, I'm visualizing it.
Instead of hard-coding the character's name into that node, you can use serialized reference to create a port that links directly to the actual character game object in your scene.
So instead of typing, you could literally drag and drop the character from the hierarchy into the node?
Exactly.
Yeah.
And because that reference is serialized, it's saved with the node graph.
So it remembers the connection.
If you load the graph later, that link is still there.
Wow, that's so much better than just typing in names. It creates a visual and a persistent link between the node and the game object.
It's a much stronger connection. And the creator had some other really insightful points about data flow.
Yeah, what else did they mention?
They talked about the importance of context when it comes to the direction of the flow. Remember how we talked about the mesh graph tool?
The one where the data flows from right to left.
Exactly. And how that's different from the visual scripting tool, which uses a more traditional left-to-right flow.
Yeah, I remember that. It seemed kind of counterintuitive at first.
It did, but they explained that with the mesh graph, it makes sense to start from the end result, the final mesh, and work backward.
Right, like reverse engineering.
Exactly. And for the visual scripting tool, the left-to-right flow just aligns better with how we usually read and execute code.
So there's a reason behind the direction of that flow.
Always. It's not just about picking a direction randomly. It's about making sure that flow makes sense for what the tool is doing.
Okay, context matters. But we've been talking about this data flow in a pretty linear way. What if we need to deal with data that needs to be accessed by multiple nodes? Or even across different graphs?
Great question. That's where the concept of a blackboard comes in.
A blackboard, okay.
Think of it like a central hub for information,
I like that, a central hub.
a shared workspace where all the nodes can communicate with each other.
Like a giant whiteboard.
Exactly. Instead of data only moving between individual nodes, we have this central location where everything comes together.
So how do we actually create a blackboard using the GraphView API? Do we have to code it all from scratch?
Luckily, no. We can use Unity's scriptable objects. We make a scriptable object class that basically acts as our blackboard.
So it's like a container for our data.
It can hold all kinds of data. Floats, strings, references to game objects, even custom data structures we make ourselves.
I see. So we've got this Blackboard ready to go, but how do we connect it to the graph? How do the nodes interact with it?
There are a few ways to do that. One option is to create a special node that acts as a visual interface for the Blackboard.
So a visual representation of the Blackboard.
Right, it's like a window into that central data hub.
Right.
Other nodes can connect to this Blackboard node to either read or write data.
So it's like a designated representative of the Blackboard within the graph itself.
That's one way to do it. There are other approaches too.
Like what?
You could also give each node a direct reference to the Blackboard.
So more direct access?
Yeah, but it might require a bit more management to prevent any conflicts.
I can see how both options have their pros and cons. It's great that the API gives us the flexibility to choose what works best for our project.
Exactly. Flexibility is key. And, the creator really emphasizes keeping the code clear and maintainable throughout these videos.
Yeah, I noticed that too. They often chose to write things out more explicitly, even if it meant a few extra lines of code.
Yeah, which I appreciate, because sometimes less code isn't always better, especially when you're trying to understand what's going on.
Exactly. It's about readability, especially with complex systems.
Right. It's like the difference between scribbling notes on a napkin versus writing a well-organized essay.
I like that analogy. If you're dealing with a ton of information, it needs to be structured properly.
Absolutely. Structure is key to managing complexity.
Yeah.
And it seems like we're building a pretty complex system here. We've got nodes, connections, data flow, blackboards.
Yeah, it's getting pretty advanced.
Yeah.
What else is in store for us? All right, welcome back to our GraphView API deep dive. It's amazing how far we've come.
I know, right? We've gone from just moving a cube to managing complex data flow. We even set up a Blackboard for our nodes to share information.
Yeah, it feels like we've leveled up big time. But I'm curious about what other tools and techniques we have at our disposal.
Well, the creator introduces this really cool concept in the second video called exposed properties.
Exposed properties. Okay. What are those all about?
So think about it this way. Let's say you have a node that controls how a character moves around.
Okay, I'm picturing it.
You could expose properties for things like the character's speed, the direction they're moving in, maybe even the animation that plays when they move.
So instead of hard-coding those values directly into the node, we're basically making them into parameters we can adjust on the fly.
You got it. It's like adding these little dials and knobs right onto our nodes.
And we have more control over how they behave. That's clever. And is it difficult to set up?
Not at all. The creator uses this simple attribute called expose property to mark specific fields within a node class.
Okay.
And then Unity's editor handles the rest, automatically creating those editable fields for us.
That's pretty slick. It's like having a little team of helpers setting up our workshop. Do you remember any specific examples of how the creator used exposed properties in the videos?
Yeah, I do. Remember that debug log node we created?
The one that printed messages to the console?
That's the one. The creator added an exposed property for the message itself.
So instead of having to go back into the code every time we wanted to change the message, we could just edit it right there in the graph.
Exactly. Makes things much more efficient.
I love it when things just work smoothly. Were there any other neat examples of exposed properties?
The creator mentioned using them to create nodes that basically function as data containers.
Oh, interesting.
So picture a node that just stores a single value. Could be the player's health, their score, anything like that.
Okay.
You could expose that value as a property, so you could set it directly in the graph and then reference it from other nodes.
So like a global variable, but in node form.
You could think of it that way. It opens up some interesting design possibilities for making your graphs more modular and reusable.
I'm seeing the potential. We could have nodes that control all sorts of things, like game parameters, player attributes, even how enemies behave.
Sky's the limit. But we've been focusing a lot on individual nodes and connections. What happens when our graphs start to get really big and complex? How do we keep things organized?
That's a great question. It's easy to get lost in the weeds when you're building something big.
It is. And that's where the creators focus on writing clear, maintainable code really shines.
Right. I remember them saying that less code isn't always better.
Especially when you need to understand what's going on. It's like the difference between messy notes scribbled on a napkin and a well-written essay.
Okay, I like that analogy. When you're dealing with lots of information, structure is key.
Exactly. And the creators shared some tips for managing complexity. One thing they emphasized was breaking down large graphs into smaller subgraphs.
Divide and conquer. It's a classic strategy.
And it makes sense to apply it to visual scripting, too. Think of it like organizing a city into different districts.
Each with its own purpose and structure.
Exactly. And guess what? The GraphView API has built-in support for subgraphs.
No way.
We can create nodes that basically act as containers for other nodes.
Okay.
So you can collapse and expand entire sections of the graph to keep things manageable.
That's brilliant, like nested folders, keeping everything tidy. What else can we do to wrangle those sprawling graphs?
Another big one is using clear, consistent names for everything. Nodes, ports, variables, everything.
Like labeling all the tools in your workshop?
Precisely. When you know what each piece is and what it does, it makes navigating and troubleshooting so much easier.
Makes perfect sense. Good organization can save you a lot of headaches. It's like having a shared language everyone can understand.
Absolutely. And don't forget about comments. Just like we write comments in our code, we can add notes and explanations directly to our nodes,
So we don't forget what we were thinking.
or to help others understand what's going on.
Speaking of others, the creator pointed out that the GraphView API isn't just for solo developers.
Oh yeah, collaboration is super important these days.
It is. And one of the coolest things about visual scripting is that it bridges the gap between programmers and designers.
Because even designers who might not be comfortable with traditional coding can still contribute to the game logic.
That's right. It's a more accessible way of working together. And they even suggest using version control systems like Git to manage the changes to our graphs,
Just like we do with code.
which is essential for collaborative projects. It lets multiple people work on the same graph without stepping on each other's toes. That's so important. So where does this all leave us? It feels like we've only scratched the surface of what's possible with the GraphView API.
We have.
Yeah.
And the creator did a fantastic job of guiding us through the fundamentals.
They didn't just throw a bunch of code at us. They took the time to explain everything clearly and encouraged us to think about how to use these tools in our own projects.
It's like they're teaching us how to think like a node-based developer.
So what's the one big takeaway our listeners should remember from all of this?
I think the biggest takeaway is this. The GraphView API isn't just a tool. It's a way of thinking. It's about embracing a more visual and modular approach to game development.
Modular. Okay.
It's about breaking down those complex problems into smaller connected pieces and empowering everyone to build the tools they need to bring their ideas to life.
That's a great way to put it. It's all about empowering creativity.
Exactly. And that about wraps up our deep dive into the world of Unity's GraphView API.
It's been an awesome journey, and I feel inspired to go out there and start building something amazing.
Me too. Until next time, everyone, keep experimenting, keep creating, and keep pushing the boundaries of what's possible in game development. See you later.